Welcome back to Water Quality in the Pacific Northwest. Today we're going to continue looking at groundwater quality. We're actually going to do a case study today. This is the 8th lecture of the course. This is our second case study for groundwater, and today we're going to look at the lower Yakima River Basin. The lower Yakima Valley area is comprised of intensively managed agricultural land. The Yakima Basin extends from the Cascade Mountains in the west to the Columbia River in the east. The Yakima River stream flow averages about 4,100,000 acre feet per year. And to save some of this water for agriculture so that it doesn't reach the Columbia too fast, there are 5 major storage reservoirs that can be found in the basin. Again, if we look at a map of the state of Washington, the Yakima Valley comprises a portion of Yakima County, and you can see here we are in south central Washington. A little bit closer view, you can see the Yakima Valley in this map. There's actually several vineyards in this valley. It's very intensive agriculture. It's quite an interesting area. This is a dry area. Here's a picture of the Yakima River flowing through some mountainous land, and you can see how dry everything is. Well, the Yakima River and basically irrigation have made this valley bloom. So it is one of the jewels in the Pacific Northwest when we talk about food production. Again, the Yakima Valley Basin is here in south central Washington, west of the Tri-Cities. And it's a pretty interesting area because it's so intensively managed and the water table is relatively shallow in large areas of this basin. You would suspect that we would have some groundwater quality issues, and indeed we do. Irrigation takes most of the water from the Yakima River. Irrigation diversions average about 2.8 million acre feet of water per year, and that's about 68% of the average flow of the Yakima River. So the majority of the water from the river goes to irrigated agriculture. Within the basin, there are 5 sub-basins that are managed a little bit independently, but basically these 5 sub-basins are irrigated areas, and there's a lot of intensive management here. Water moves from the Yakima River to irrigated fields using a series of canals. That's pretty common in the western of the United States. So the focus of this short presentation today is to look at this basin and focus a little bit more on the Toppenish-Benton sub-basin, which covers about 1,500 square meters. 1,500 square miles, excuse me. The lower Yakima River Basin is a groundwater management area within this sub-basin, and being a groundwater management area, it receives extensive regulatory boundaries, and that also means that it's managed pretty intensely by many different local community groups. I said the key to the Yakima Valley is intensive agriculture. The climate is very warm here. Lots of different crops are grown here, and with lots of different crops and intensive water management, lots of pesticides are used in the basin. There's a lot of worry about the quality of the water for the residents of the basin and the quality of water as it leaves the basin. I had mentioned just a few moments ago that agriculture is the big industry in the basin. 70 to 80% of the land in the basin is irrigated. The crops grown in the basin are very diverse. There are lots of orchards in the basin. There's vineyards. A lot of hay or alfalfa is grown. This is probably the largest hop growing area in the United States. Peppermint and spearmint are crops, and many, many, many different other vegetable crops. And if we just look at them very quickly, um, we can see orchards, and there's apples, there's pears, there's cherries, there's all different kinds of orchard crops. Vineyards. Vineyards have come into the valley very strong. Many vineyards are here. There's several different wine areas located in the Yakima area. Up here, the Yakima area, there's several different wine areas, and it's become a very productive and valuable industry for South Central Washington and the Yakima Valley in particular. Hops. Hops are a crop that aren't grown extensively across the country, but a significant portion of the hop acreage in the country is in South Central Washington, particularly the Yakima Valley. Hundreds of thousands of acres of alfalfa are also grown in the valley. You can see at times up to a third of the acreage in the valley is alfalfa hay. And there are lots of vegetable crops. Here's an example of alfalfa coming up. So very, very diverse crops, which causes some of our problems when we talk about groundwater quality. But in addition to our crops, there's a dairy industry. There's a lot of dairy, and they're concentrated near the small towns of the Yakima Valley. So again, overall, we have very productive farmland. Here's a great vineyard in the fall. Another thing we need to talk about when we talk about groundwater quality in the Yakima Basin is the fact that we have all these intensively managed crops, and they produce high yields. Well, when you have an intensively managed crop, you're probably using substantial amounts of nitrogen fertilizers. So substantial amounts of nitrogen is applied to cropland, and this has been so since the 1940s, when commercial fertilizers became available shortly after 1945. It's traditionally, we've used commercial fertilizers for our row crops and most of our crops grown in the valley. Recently, with the dairy industry, people have also started to apply manures or animal waste to their crops. But by far the majority of the nitrogen fertilizer used would be associated with commercially produced nitrogen fertilizer. We've talked about nitrates already as we've covered groundwater. A lot of those principles that we've talked about are very applicable to the Yakima Basin. If we take a look at drinking water, we look at the people in the valley. 66% of the people living in the Yakima Valley get their service of water from public water systems. So you've got towns and municipalities that control the quality of the drinking water for 2 out of 3 people. However, a third of the people are served by private wells. And some of these wells are pretty shallow, which means they're pretty susceptible to pollution. There's lots of people that have wells that are only 8 to 15 feet deep. You combine that with intensively used nitrogen fertilizer and lots of pesticides, there is a potential for groundwater contamination. We look at the valley from a population standpoint. If we look at entire Yakima County, there's about 250,000 people that live in this county. Those are 2020 estimates, about 251,000. Of that 251,000, 94,000 live in the town of Yakima. What I think is really interesting is if you look at the drinking water consumed by people in Yakima County, about 37% of the people get their drinking water from surface water sources, and the other 63% depend on groundwater. Well, this number, 37%, is very interesting because Yakima comprises about, the population of Yakima is about 37% of the county's population. So basically, the rural residents and all residents of the smaller towns in the Yakima Valley get their water from groundwater, while Yakima gets its water from surface water, and they treat the surface water. So Yakima's water source is the Natchez River, but all the other small communities in the Yakima Valley, and there are many of them, they get their water from groundwater, and all rural areas are on wells from groundwater. So wells supply the third of the people, 2/3 of the people in Yakima County. There are some things that are unique about Yakima County that we need to consider when we talk about protecting groundwater quality. The first is Yakima County has a pretty high poverty rate. It's greater than 20%, which puts it in the top 20% of counties in the country as far as poverty is concerned. Education is a problem in Yakima Valley. Well over 30% of the residents do not have a high school diploma. It's been estimated that this percentage of adults is closer to 40% of the people, of the adults in the county, do not have a high school diploma. 48% of the population can be classified as Hispanic or Latino. Remember, it's a valley where there's a lot of farm work. A lot of farm workers are drawn here for jobs. The high Hispanic population gives this county 4 times the state average of Hispanic population. So there's a concentration of Hispanics here. And there is also a concentration of Native Americans here. We have the Yakima Native American Reservation here, and Native Americans comprise about 6% of the population. We need to consider that with a large Hispanic population, that English is probably not the primary language in many households. Traditionally, we haven't produced outreach materials in Spanish. There are some outreach materials in Spanish, but a lot of these are limited. And because you have a fairly uneducated population in the county that works in agriculture, written materials and the internet may not be the best way to access or provide materials to people that we consider at risk in the population. So those are all things that have to be considered when we take a look at the Yakima Valley groundwater management area. We also have some outside considerations that we should think about. If we are going to do outreach in the Yakima Valley to protect groundwater quality, we need to coordinate with the Yakima Indian Nation and with the Indian Health Service. They reach a significant portion of the population. And most of the Native Americans in the valley are on groundwater. We need to coordinate with Heritage College. Heritage College is a Hispanic serving college. So if we're going to provide good outreach here, we need to consider that. In addition, agriculture is the lifeblood of the Yakima Valley. So when we talk about protecting groundwater, we need to talk about local community groups. We need to talk about agricultural groups. We need to talk about different business groups. All of these people need to be brought to the table if we're going to talk about protecting groundwater quality. Well, you have a lot of diverse people with diverse incomes, with diverse language skills. If you're going to put together a good outreach program that will have a positive impact on groundwater quality, you have to stress cooperation, coordination, and you have to have a consistent message. You can't change the message year by year depending on what the flavor of the year is. So we have to have cooperation, coordination, and consistent messages about shared goals that we should have to protect groundwater quality in this basin. We need to be able to support effective public health education and outreach activities in a coordinated, cooperative, and consistent form. A lot of people have come up with what they think are the sources that cause groundwater contamination in the Yakima Valley, and I'd like to go through some of these for a few moments. First of all, you're going to see a series of tables with the source of potential groundwater contamination in the left column, how that groundwater contamination gets into groundwater, what are the contaminants, and what is the cause of groundwater contamination. So in this first table, our source is going to be agriculture, farming. The pathway may be land application of fertilizers. The contaminant, nitrate nitrogen, and the cause would be when people are applying too much nitrogen fertilizer, or they're applying fertilizers at the wrong time of the year and or over irrigating. Another pathway of nitrogen getting into the groundwater is through irrigation water. And this would be over irrigation, runoff water from irrigated fields, the return flows and the drains may have a lot of nitrogen in there that contaminate the groundwater. And the contaminants we're worried about, again, are nitrate nitrogen, salts in the ground, and pathogens. And we'll cover each of these sources a little bit later and separately. Another portion of the source of groundwater contaminants in the valley may be agriculture, dairies. And a lot of dairies have lagoons. These lagoons, if they're not properly operating, can put nitrate nitrogen, total killed-all nitrogen, which is total nitrogen, salts and pathogens in the groundwater. And the cause of lagoons causing the trouble is if they're improperly constructed or they're improperly managed. Dairies can also provide problems from drainage, from processing water transfer. And the pathogens could be nitrate nitrogen, not the pathogens, the contaminants could be nitrate nitrogen, total killed-all nitrogen, salts, and pathogens. And again, improper construction or management is the problem. Some other problems associated with dairies include stormwater management. They can put nitrates, total killed-all nitrogen, salts, and pathogens in groundwater. And again, it's all about improper construction and management. And then the dairies produce animal waste, and farmers are using this animal waste as a source of nitrogen, so they apply the animal waste to the land. And if the animal waste is not properly applied at the proper times of the year and with the proper equipment and at the proper rates, we can get nitrates, salts, and pathogens that leak into the groundwater. And the biggest cause is usually they apply too much manure. They apply manure that contains nitrogen at values that are higher than the agronomic rate or the rate of the amount of nitrogen required by the plants to produce an optimum yield. Agriculture, we got feedlots. A lot of confined animal feeding operations. They impound stormwater. If they don't construct these stormwater impoundments right, you've got nitrates, total killed-all nitrogen, salts, pathogens, and pharmaceuticals from the animals themselves that are given to the animals themselves that could leak into the groundwater. And to stay with ag, we've got wells. A lot of people have their individual wells. You can get backflow into the wells and leakage around the annulus or the wellhead. And you can see nitrates introduced directly into the aquifer this way, salts and pesticides. So again, improper construction, lack of wellhead protection, they're all pathways to get contaminants into the groundwater. If we go to rural homeowners and people that aren't on sewers, they have septic tanks and leach fields or drainage fields. If they don't manage their water correctly, the septic tanks, if they're not properly constructed, if they're not maintained right, or if there's just too much waste going into a particular system, again, nitrates, nitrogen, salts, pathogens, and pharmaceuticals have a pathway to leak into the groundwater. We have a lot of abandoned wells. And if abandoned wells are not properly closed, any water movement can move down through these abandoned wells. And if in the water we have nitrates or salts or pathogens or pharmaceuticals or pesticides, they can be directly introduced into the groundwater. So there's all sorts of ways that we can get the groundwater contaminated here. And it's a real problem, particularly when we have where we have groundwater that's pretty shallow. And then finally, people living in rural areas that have their own domestic wells, they have to take care of the domestic wells, backflow into wells. All wells should have backflow prevention devices so we can't directly introduce contaminants to the aquifer. If we have leakage around the well annulus, or what we call the wellhead, we can get nitrate, salt, pathogens, pharmaceuticals, and pesticides leaking in to the groundwater. So we've presented a lot of ways that contaminants can get into the groundwater. And when you've got 250,000 people in a county with very intensive agriculture, the threat to groundwater quality is great. Well, Yakima County came up with a plan in 2015. They wrote up a plan to protect groundwater and some of the steps that they should take. And I'm going to briefly go through these steps and give you an idea. Water quality and water quantity are very important considerations for the overall county plan of protecting water and protecting their resources. There are critical things that Yakima County said that they need to address. One is groundwater and aquifer recharge. The premise is that groundwater is the primary source of drinking water for rural residents and all city residents in Yakima County except for the town of Yakima. And that's where we got to that 67% of the people getting their drinking water from groundwater. So groundwater is a very valuable resource. Once contaminated, groundwater may not be usable. And this could negatively impact up to 160,000 residents of the county. So let's take a look at a couple goals that the commissioners in Yakima County wrote to address this. Goal statement: to maintain and manage the quality of groundwater resources in Yakima County as near as possible to their natural conditions and in compliance with state water quality standards. So the Washington Department of Ecology had a lot to do with the standards and the goals that Yakima County has to protect its groundwater resource. Within the management plan the county commissioners put together, there are 15 or 16 steps, or 15 or 16 objectives that they have, and I want to cover the objectives very quickly that have to deal with groundwater quality. Statement number 7. Basically, residents depend on groundwater for their drinking water, yet groundwater contamination is a major problem. The commissioners say we need to minimize risk to groundwater for new developments. We need to identify and mitigate existing threats to the quality of groundwater. And remember, we're talking about 160,000 residents, both urban, rural, and agricultural, that are negatively impacted if groundwater gets contaminated. Specifically, goal number 6 that the county commissioners put out there is to protect the quality of groundwater used for domestic water supplies. And they can use existing regulations or write new regulations to meet this need. From a policy standpoint, Here are some things that they are trying to do: to enforce existing regulations regarding well construction and abandonment. So people have to get permits. The health district has to inspect to show that these newer permitted wells meet regulations to protect groundwater quality. Second policy, to implement a long-term groundwater quality and quantity monitoring program for basins that provide domestic water. So let's see how our aquifers are doing. Are there contaminants down there? What are they? And how are these contaminants change over time? Thirdly, Yakima County is a growing county. The city of Yakima is not growing, but all the small outlying communities and the rural areas are growing. So 6.3, minimize impacts of development and agricultural practices on groundwater supplies. Now, some of this can be done by regulations, but a lot of this can be done with community groups. If you tie everybody in the community that has an interest in groundwater protection together, grassroots level can do a lot of positive things. Policy 6.4, establish and enforce septic tank regulations. If people aren't on sewers in the rural areas, of course they aren't, make sure that people follow septic tank regulations. They're built right, they have large enough drainage fields, and they're maintained properly. And then finally, develop and enforce a wellhead protection program. All of these seem logical. A lot of these things are in place, but a lot of things, again, have not been widely used. Another statement in the Commissioner's plan is to manage groundwater to ensure the health and safety and welfare of Yakima County residents. Going through a few goals here: ensure the safety of public and private potable water systems. Protect these water systems. Some of their policies: implement a satellite management program for new or failing water systems. Ensure that water services for new developments comply with applicable laws and regulations. Review water plans to ensure that they are compatible with land use planning. 8.4a, require water systems to satisfy current regulations when they expand service. You got to remember, a lot of these small communities are growing fairly fast in Yakima County. So you got to make sure that as you take more water out of the ground, you have to expand service, maybe put in a few more wells, that they satisfy current regulations. And when you put new people on the system, make sure that new customers pay their fair share of costs for meeting the standard. The burden shouldn't go only on the existing customers. To allow for new services, services for existing customers may have to be reduced. If you've got a community of 3,000 people and the water system is built to handle 3,000 people, and if they are maxed out, if you have more people moving into the community and the county commissioners approve of this growth, you may have the same amount of water, so you actually have to reduce the per capita water consumption through education or regulations to meet the water need. And then support efforts of privately owned public water systems, get them up to public standards, at which point, if these private systems can be brought up to standards, it may be that the county will take them over to consider the ownership and operating them to protect the water. Another goal, goal 11, is to protect surface and groundwater quality and quantity, and have policies such as development proposed for individual wells and septic systems should be allowed only at densities that meet self-sufficiency standards. For instance, if you're looking at septic systems, you have to have a certain amount of land for a drain field. So you can't have high-density development if people are on septic systems. because they need a minimum amount of land. That's all it's saying. You can't overdevelop areas and have septic systems and expect them to work. Identify the intensity to which a parcel can be used. You can't overdevelop a parcel of land based on regulations that for health and safety for people. Encourage appropriate use of community public water and sewage systems. We look at another goal here. Let's look at UT 13. For rural water, ensure groundwater resources are safeguarded to protect public health and welfare. Generic statement, but what kind of policies do you have? Limit the number of wells penetrating the aquifer to protect groundwater quality and supply. That aquifer is not a never-ending source of water. Let's limit the number of new wells that can penetrate the aquifer. Every new well that penetrates the aquifer has the potential to contaminate it. Encourage the use of community water supplies. So the towns have water supplies that are managed by the utilities, and they have to meet regulations. Establish monitoring and testing and maintenance program for community wells. Establish a well tracking program for all wells producing under 5,000 gallons of water per day. Establish well location standards. That wells have to be located on higher areas in the landscape so that contaminants don't flow down into the wellhead. Establish construction standards for community wells. And evaluate what the state of Washington has given the locals to work with. Evaluate Washington's Department of Ecology's well construction standards and use them where appropriate. Encourage the development and consolidation of community water supplies through county application for water rights for cluster development, establishing financing methods for public water supply. So all of these things are part of this. Encourage the development and consolidation of community water supplies through, we talked about the first two, and developing latecomers fees to compensate. If somebody moves into the area new, they have to pay their fair share to encourage the use of existing water supplies, not put an undue burden on existing supplies. Okay, with all that information of what the commissioners have in their long-term plan, let's take a look at our potential sources and what we know about groundwater quality within the valley. So if we take a look at potential sources of groundwater pollution based on recent studies, there are 4 potential or major sources of groundwater pollution. Worried about the dairies and feedlots. Remember, we showed 6 areas of pollution there. Worried about irrigated agriculture. Worried about urban and residential areas for their wells. And they're worried about spray fields and wastewater management. Lots of times wastewater and food products for processing are sprayed direct, the waste is sprayed directly back on the fields. So if we look at some dairy information, compared to Idaho, dairies are not as big an issue in Yakima County because there's a lot fewer. If we take a look at some of the dairy information we have for the Yakima Valley, on the left column we have the number of dairies, the number of acres that dairies occupy, and the total amount of nitrogen that's produced from those dairies, which has to be used or gotten rid of, just not fall into the aquifer. There's 68 dairies in the Yakima Valley. 43 of them are large, which means they have significant numbers of animals. These are confined animal feeding operations, and there's not a lot of mom and pop dairies. Only 4 of the 68 are mom and pop. Collectively, all dairies occupy about 28,000 acres in the Yakima Valley. Most of those acres are for the large confined feeding animal operations. When you add 4 and 43 together, you don't get 68. I didn't put a column in here for medium-sized dairies. If we take a look at the 68 dairies in the county, the number of acres they occupy, these 68 dairies provide about 34 million pounds of nitrogen per year in an organic form. Somehow we have to make sure that 34 million pounds of nitrogen doesn't go down into the aquifer. Generally, we apply the manure from these dairy operations back to farmland on an agronomic rate. Second source of pollution is irrigated agriculture. Large quantities of inorganic, which is commercial nitrogen, and organic manure, nitrogen fertilizers are annually added to valley soils. It is likely that this is a major source of nitrogen in groundwater in the Yakima Valley. Any nitrogen that moves below the root zone of plants has the potential to enter the aquifer and contaminate groundwater, particularly if the water table is shallow. Now, one of the ironies here is soils in the Yakima Valley have high soil pHs. That means they have a lot of salts. Farmers intentionally over-apply water to leach some of the salts out of the soil. You need to get rid of the salts to make the soils more productive. It improves crop growth and it improves the soil health. So if you're actually intentionally leaching salts out of the environment, you're actually leaching significant amounts of nitrogen also, and that is a problem. So irrigated agriculture, for wellhead protection. From an urban and residential standpoint, there's lots of abandoned wells around. You've got to make sure that those abandoned wells are properly closed so that things don't flow directly down those old wells into the contaminate the aquifer. You need to check the construction of the existing wells. Make sure they're constructed right and make sure there are just no empty holes that water can flow down. And you need to take a look at land development because there's always a call for newer and more wells. The other source of potential pollution would be spray fields and wastewater management. And this is basically the application of biosolids from wastewater treatment plants or from food processing plants back to cropland. Right now in the Yakima Valley, there's 7 to 9 facilities, non-dairy facilities, that spray biosolids back onto soils. These facilities are required to conduct groundwater monitoring. These facilities are required, they have to show they're only allowed to put a certain amount of biosolids back onto the land so that they do not leach into groundwater. What about pathogens? When I think of a pathogen, I think of something associated with human or animal waste. We measure bacteria associated with human or animal waste. We measure what are called fecal coliforms or coliform bacteria. Coliform bacteria by themselves are not harmful to humans. Rather, they're an indicator of animal or human waste, the presence or absence of animal or human waste. People have conducted pathogen tests or coliform bacteria analyses in this valley since 1991. The primary measurements are of coliform bacteria. It's an indirect measurement of human and animal waste. If coliform bacteria are present in the water sample you collected, you can assume that animal or human waste have been introduced to the groundwater, which is bad. Usually deep wells are deep enough that you don't really have animal or human waste introduced into them, so you shouldn't find coliform bacteria. However, if your well's only 7, 8, 9 feet deep, you have to manage that well, you have to manage that well right so that these animal or human waste organisms do not get down into your water supply. Now, a lot of people have looked at pathogens in the groundwater of the Yakima Valley. There's three major sources of data historically that tell us how pathogens are doing. If we take a look at communities that provide water to residents, they're required by law to monitor their water supplies. So they get coliform bacteria samples all the time. The United States Geologic Survey has done several water studies within the basin. So they have conducted and taken a lot of samples for coliform bacteria. And within the valley, there's an organization called the Valley Institute for Research and Education. In 2002, they did an extensive study of coliform bacteria in the groundwater. What the results showed were that shallow wells are much more likely to be contaminated with human or animal waste. Deep well contamination is unusual. Usually the wells are deep enough that you don't find the coliform bacteria there. But coliform bacteria has been detected in wells that are deeper than 300 feet. So just well depth alone doesn't make the difference. If we compile the results of studies conducted in the Yakima Valley and we look at the depth of the well, shallower than 15 feet, 15 to 300 feet in depth, or greater than 300 feet, and we look at the number of wells looked at over since 1991, the last 30 years, that's a pretty good group. We basically have over 300 well samples. And if we take a look at the percent of the wells that are contaminated with E. coli, which means that we've got animal or human waste introduced into the aquifers, only 1% of the wells that are deeper than 300 feet are contaminated. 9% of the wells that are between 15 and 300 feet are contaminated. And wells that are shallower than 15 feet, fully more than a quarter of the wells are contaminated. So there definitely is something there between well depth. Now, coliform bacteria should not be detected in wells unless there's unsanitary wellhead conditions where dirt, surface water is allowed to enter directly into the well. And again, we go back to the commissioner's rules and regulations, how their rules and regulations are meant to try and prevent this. If you have a break or a leak in your service line, bacteria can be introduced. And maybe local sources of contamination are putting the coliform bacteria into the wells, such as leaking landfills or cesspools, or actually directly contaminating the aquifer. In addition, people that have their own wells, when they have their wells serviced or constructed, they have to shock chlorinate their wells to kill all bacterial organisms, pathogens. If they don't disinfect their wells using shock chlorination, or they do it improperly, they may be introducing coliform bacteria into the groundwater. And if they do a shoddy job of constructing a well, certainly that's just a way for some of the contaminants to leak into the well through the soil surface. Okay, if we take a look at nitrate nitrogen, we've talked a little bit about it indirectly. There have been lots of studies looking at nitrate nitrogen levels in groundwater in the Yakima Valley. There have been major studies in 1985, 1997, 2004, and 2010. All of these studies have indicated that nitrates are a concern in local groundwater. There was a study in 2017 that actually looked at nitrate levels by month. So there's some pretty extensive data. If we take a look at the 2017 study First, a total of 1,059 samples were collected from 156 wells and from surface drains. Basically, surface drains are the collection of irrigation water that's been run through fields and has been retained at the bottom of the field, and that drain water is reintroduced into the water so it can irrigate another field. Lots of times these drains contain fairly high levels of nitrates. This particular 2017 study was conducted by the U.S. Geological Survey. Now, the results are what are important, not the methodology. Nitrate nitrogen levels range from 0.04 to 45.2 parts per million in private wells. Nitrate nitrogen values range from 0.04 to 25.8 parts per million in drains from the bottom of fields. The average, 6.1 parts per million in wells, 5.5 parts per million in drains. The drinking water standard for nitrate nitrogen is 10 parts per million. So the average values are below health standard guidelines, which is good. We're below 10. However, those values are much higher than what we would expect as a background level of nitrate nitrogen. So there has been introduction of nitrates into the aquifer, but not to a point that most of that water is unsafe for human consumption. Of those 1,000 wells, drinking water standards were exceeded 20% of the time in wells. 1 out of 5 wells had too much nitrate in it for regular human consumption. 13% of the drain water exceeded 10 parts per million nitrate nitrogen also. So 26% of the wells that were evaluated exceeded the drinking water standard at least once. Remember, 20% of the wells had an average above the 10 part per million drinking water standard, but 26% of the wells exceeded that nitrate nitrogen standard of 10 parts per million at least once during the sampling cycle. 36% of the drains that were evaluated exceeded the drinking water standard at least once during the study, even though on average only 13% of the drains exceeded. Now, nitrate nitrogen was not detected in 13% of the samples. 15% of the wells, they didn't find any nitrate nitrogen. 5% of the drains, no nitrate nitrogen. So if we look at 30 plus years of nitrate nitrogen well sampling in the Yakima Valley, and we look at the left column here, nitrate nitrogen values less than 5 parts per million, between 5 and 9.9 parts per million, and greater than 10 parts per million. Remember, the drinking water standard is 10 parts per million. 67% of the wells contain less than 5 parts per million. The water is considered safe for human consumption. 21% of the wells contain between 5 and 9.9 parts per million. These wells are considered safe for human consumption, but these nitrate nitrogen values are elevated. We better have some best management practices on the ground to make sure that these nitrate nitrogen values don't creep up in these wells. And then 12% of the wells had more than 10 parts per million, and we don't consider these wells safe for human consumption. So that kind of gives you a background on nitrate nitrogen levels, and going back to what the county commission steps the county commissioners want to put in play. You can see why. And then finally, we'll just take a dab at pesticides for a few moments. Pesticides are very difficult because, first of all, Yakima Valley is very diverse in the crops that are grown. Over 150 different pesticides are used in a season in the Yakima Valley. It's way too costly to have an extensive monitoring program for each pesticide. A nitrate nitrogen sample costs about $12 to run in a laboratory. A typical pesticide runs between $150 and $300 per sample. Very expensive. There is a small pesticide database on groundwater contamination in the county, but it's not extensive simply because of the cost. Consequently, when we talk about groundwater quality in the valley, pesticides should be grouped into 4 categories. 1, pesticides that are applied that are highly leachable and they take a long time to degrade. Pesticides that are applied that are highly leachable, but they break down in the soil pretty fast. Pesticides that are slightly leachable, but they last a long time. And then pesticides that just don't leach. If we take a look at these 4 categories, we should be concerned about the pesticides that fall into categories 1 and 3. Again, category 1, if it's a highly leachable pesticide and it lasts a long time, there's a good chance that that pesticide eventually might get into the groundwater. And then category 3, a slightly leachable pesticide that's long lasting. It doesn't leach very fast, but if it's leaching in a soil where the water table is only 7 or 8 feet deep, it can get to that water table. So we need to worry about the pesticides that fall into categories 1 and 3. Pesticides that fall into category 1 should be treated like nitrates. They're likely to leach. You have to employ good management to prevent them from contaminating groundwater. Best management practices, or BMPs, should be established for nitrates, should be used for category 1 pesticides, and they probably should be used for category 3 pesticides, although not at such an intensive scale. So we don't have all the pesticide data we would really like to have in the Yakima Valley, but we need to classify pesticides based on leachability, and the leachable ones we should manage like we manage nitrate, whatever BMPs we can employ to reduce leaching. So that gives you a snapshot of the Yakima Valley. There's a lot that's known, there's a lot that's unknown, and it's a big challenge to keep groundwater clean in the valley because of such intensive agriculture use and because of such intensive use of wells for domestic water supply. Thank you for your attention. Over irrigation, major source of nitrogen. We move to residential areas, residential and urban. We're talking, people that have, a 1/4 acre lot, people that may have 3 or 4 acres. They're in a semi-rural to an urban environment. They are potentially contributing pollutants to groundwater by their fertilizer use. If they're over fertilizing their gardens or their lawns, some of that nitrogen may leach. If they have septic systems, which they probably do, if their drain fields are not large enough or their septic tanks are not maintained properly, some of the nutrients overflow and go directly in high concentrations into the soil, which can leach into the groundwater. Some of these people have wells that aren't located in the right spots. They're located in low areas, which means from a topographical standpoint, the contaminants can flow downhill and directly enter the aquifers. So there's lots of things that need to be considered. That's why the county's plans are so detailed, because there's so many different potential sources. So in addition to fertilizer use, septic systems, and color, it's a very valuable area economically in the state of Washington.